We are making every component of the car by hand because we're not a Detroit car manufacturer. We're just a bunch of guys in a shed trying to knock this thing out.
We exist in a vast space, and other worlds are merely points of light. For millennia, we've created images and stories to go with them. The ancient Greeks gave us Orion, the hunter. This is the Big Dipper, but it's actually part of Ursa Major, the Great Bear. And in a remote corner of the universe, standing alone, a new constellation created from the mind of Dave Klym. He named it the suspension pickup points for the front subframe of RazzoFab. It rolls off the tongue. If you don't know what RazzoFab is, watch the first few episodes. Back to Dave. What has come from his beautiful mind? 2 upper front rockers and shock mounts, 2 control arms and radius rods, aka drag links, even a steering rack and anti-sway bar mounts. All these points perfectly aligned in X, Y, and Z space. Not from a production team, but conjured up in Dave's own head. Just figured it out on his own, with no witnesses. Come to think of it, why did Dave put those points there? They could be all wrong. He said there's also pickup points in the rear where the engine is, but what if he got those wrong too? And out here in space, no one can hear you scream or squeak or rattle. Automotive mass is strictly Newtonian and can only move 3 ways: forward and back, up and down, side to side. Dave plugs in parameters, things like wheelbase length, total weight, and horsepower, and comes up with the suspension geometry. Dave's used to building race cars, where the only 2 goals are safety and speed. Riding in a race car can feel like going over Niagara Falls in a barrel, but RazzoFab also demands handling and comfort. It shouldn't feel like going over Niagara in a barrel. It should feel like going over in a Barcalounger, a very fast Barcalounger. A proper suspension must deal with angular momentum, which is the tendency of a body moving in a direction to continue in the same direction. When a car turns, the moving mass resists, so throughout the turn, the car rolls to the outer side of the turn. To oppose angular momentum, Dave had to pinpoint roll centers and apply an anti-roll bar, which ignores up and down movements, but acts like a spring during side-to-side movements. Since we're focusing on the front suspension, we're going to look at the dynamics of bump steer and diving. When you hit the brakes, the car momentarily becomes heavier in the front and the nose plunges down. Bump steer is what happens when you hit a bump or dip, causing the front suspension to move up or down, making the car steer to one side or the other. You've got to design or adjust that out of the car, or you risk having an argument with your steering wheel about where you're headed. The info in this quick review can be found in greater detail in the first 3 episodes. Dave was limited in his design by the tough constraints of the RazzoFab Challenge, a Subaru engine mounted in the rear with all-wheel drive. One of the first decisions was a straightforward one. Nothing in the original Fiat suspension system could be used, nothing at all. Too small, too weak, too imprecise. So the project is not a retrofit, it's an entirely new car with a new engine, new drivetrain, new suspension, and a wholly new chassis. After Dave selected tires and a brake package, he could begin to knit things together in his mind. He went to work first with pencils, then moved on to CAD calculations. On the RazzoFab build map, you are here. Dave has designed the suspension, but before a single piece of metal is cut, his calculations must be thoroughly vetted. Randle Engineering in the UK is one of the most respected automotive engineering shops in the world, so of course they were best able to evaluate Dave's initial suspension design. Tell me the role that Randle Engineering played.
Okay, we sent all the data to Randle Engineering, all the pickup points, X, Y, Z coordinates. I mean, pages and pages.
Dave started us off with, this is the rough package, this is where we're going, this is where I've got to. And then we thought, wow, what a crazy idea, that's brilliant, we'd love to be involved.
We're looking just from feedback from you, your initial thoughts of the suspension geometry, your analysis, and then improvements.
Firstly, great to see you again, Dave. It's been, when I reminded myself what we did, I thought, crikey, what does the suspension actually have to do to give you the vehicle performance you want? And that was kind of where we then fed those numbers into Dave. That was the sort of first task from memory, was getting those targets nailed for what is quite a peculiar vehicle. I've been reminded, having looked through the documents, when we put, Dave's, design in against the targets, we said, it was pretty close across the board. I think there was sort of only 3 areas out of, I'm talking 50 areas that we fed back on and ultimately tweaked. We work with some large car manufacturers who don't get that close, so it was a really good process from our point of view.
Yeah, I think the biggest suggestion was the anti-squat and anti-dive. I mean, that was the most radical thing. I couldn't believe in rear suspension. I think I called you and asked.
You checked we hadn't made a mistake.
You and your folks had also suggested some minor changes in wishbone design, things like that. Because I was doing this by myself with no backup, nobody. So it was really good to have you looking at something and say, "Why don't you do it this way?" And I thought, yeah, I'm glad you suggested these things, and we were able to incorporate those into the final design.
Yeah, we made some suggestions on that front, but I think you had 99% of it covered, which is quite remarkable for a whole vehicle.
Besides dive and squat, one of the other optimizations offered by Randle Engineering had to do with Ackermann. Herr Rudolf Ackermann. This is a representation of Ackermann geometry. So is this. So is this. Ackermann, in the context of steering, refers to a specific geometry which ensures that a vehicle's wheels turn at the appropriate angles. In our example, the right wheel making a left turn has to travel a greater distance, but using a smaller angle than the inside left wheel, which travels less distance, but at a greater angle. Rudolf Ackermann was both an engineer and a patent clerk, so he filed the paperwork, although other sources are also named as originators of the calculations. Still, Rudolf Ackermann, who lived in the age not of cars but of buggies and carriages, is sufficiently famous to have his own jigsaw puzzle.
I've never had any experience building cars. I had no idea how it was done. My concept of building a car was calling your hot rod store or your parts distributor, ordering high performance upper control arms, lower control arms, and then having us build it and assembling all together. That was my concept of building a car. I didn't think it was worth spending all this time building fixtures to then make a car. It's like, you're really gonna take all that time to build one piece. It seemed unfathomable that somebody would take so much time in building the fixtures and tooling to create one component. But if any of these pickup points are anywhere out of precision or out of place, it's gonna affect everything and throw all of this engineering and research and development that was worked into by Randle Engineering, by Dave Klym, out of the window.
Think of fixtures as extremely precise platforms or scaffolds. Designing and building a fixture is often as time-consuming as creating the car part the fixture was designed to help produce. Fixtures allow fabricators to build components to extremely precise tolerances. In a high-performance car, if you're off a couple of millimeters, you might as well be off by the Grand Canyon. We've already shown you the steel table, where Dave and Pedro built the center keel, the table itself being a kind of fixture. In the last episode, we looked at the fixture Dave designed to build the uprights. Remember, it was reversible. Devilishly clever. Dave only had to build one fixture to produce both the left and right uprights. But one of the best examples of fixtures is the one Dave built to produce the front subframe with its unyielding suspension pickup points, the namesake of Dave's Starfield constellation. A helpful hint for our non-fabricating viewers: if it looks like steel, it's part of the component. If it looks like aluminum, it's part of the fixture.
What I did this morning is I welded everything on this component that I didn't weld before because it was upside down. I couldn't get to all the welds. So now everything is welded and it still fits. It's a good sign. I don't care if it's too wide because I can compensate for that with shims.
The size of the spacers that you use.
Yeah, and I'm using 30 thou shims.
Yep.
But if it's too narrow, then I have no room to play with it. So.
Yep. So are you planning to weld in these bushes at this point then?
No.
Right, you're still going to keep that till last.
Last bloody thing, yeah, because I got all the welding to do here. You know, we got that this doubler plate here. That's quite a bit of welding.
Yep.
You know.
Mm-hmm. And that'll have a tendency to cup this thing this way.
Yeah, it will. Mm-hmm. So
Okay.
I'll just keep these little sticks in there until we're done. I've got to clearance this a little bit because I welded this, so I've got to clearance this a little bit. I'll be right back. Go next door. Need help, Tim?
This is what Pedro is talking about with fixtures being time-consuming. Dave is making a tiny adjustment not on the component, but on the aluminum fixture for a better fit with the subframe. At the margins, there's a millimeter by millimeter dance between the fixture and the part. The relationship is consummated by a white-hot complete weld, which, absent the fixture, would turn out to be a heat-distorted mess. On to fabricating the front suspension. We're going to focus on the upper control arm, especially the pivot tube. Once again, look for those fixtures.
This is the fixture, the platform for the tooling, and then those are all the different tooling that's going to be used. But that's the pickup points that you see in that screen. You see that arm right there? That's this right here. You see that?
What is it?
It's called a front upper control arm pivot tube. You see that pivot tube? That's the pivot tube right there. So that's on this fixture at the height that it needs to be, at the spacing that it needs to be. So that gets bolted onto here so it doesn't move. And then this front upper control arm upper outer skin is what you see here. It's in Dave's hand. You see that right there? That's this rear, the upper control arm upper outer skin, which is this right here. So then that's going to be placed around this pivot tube and attached with a pickup point on that tooling right there, where that's at a specific precise point where it needs to be. The more precise that is, the better it's going to weld, the stronger it's going to be, the better just everything aesthetically also looks and works. So everything's tacked, and the reason why you tack it is so it doesn't distort. When you tack it, you're creating a stitch here, a stitch here, a stitch here, a stitch here. So you're stitching this whole component or part together. And then once that's stitched together and all fixed on these points, then you can start welding the whole piece together.
Yeah, I've heard him use the term sneak up on it.
Yeah, you literally have to sneak on it because you can't add. So he's literally creeping up on it, and he'll bring it back on the tool. And see, now he's making sure that all fits perfectly around there. So you see the space here? That allows him to get the welder and weld around here and get it around here and weld all of it together. If that aluminum spacer wasn't here,
Yeah.
he wouldn't have
So
space.
you're saying the spacer really serves no purpose except to push this away from this solid
Yeah,
brick.
and give you a
And
working
give you a
room.
working space.
Yeah.
So you can get in there.
Yep. But that's
Gotcha.
because that needs to be there so you can weld around it.
This control arm actuates a shock absorber and a spring, which is inboard. The reason I'm doing that mainly is for space considerations. I needed some room. You can see the shock absorbers are adjustable. This is an adjustable front sway bar. And we have rack and pinion steering here. It's a steering rack that connects both front wheels.
And here it is, the first video of the fully operational front suspension.
Hey, how fast do you want me to go for you? That's about fast enough. Okay, you want to do it again? Yeah.
This is not a delicate system. This is basically a racing suspension system. This video is trial run stuff, but it does prove in its own humble way that things are working the way they're supposed to.
You can see all the adjustments that the steering has, so we're able to configure the car to any type of setup that we need within certain parameters. We're able to see the axles. You can even see small parts amount of where the differential is mounted and how small all the packaging is. You can even see some of the parts where how tight the cooling pipes. All these pipes carrying coolant, they have to go through the space where the shock absorbers are mounted, the differential is mounted, the steering rack is mounted, all of that in this front little subframe that we saw in that video. So, I mean, everything is very tightly packed. So it's a good shot of how tight everything is packed into there. But yeah, that's pretty much it.
Next episode, we'll take a look at the rear suspension and find out what had Dave so concerned.
I couldn't believe the rear suspension. I think I called you and asked.
You checked we hadn't made a mistake.
Remember to join us for episode 5. We'll tackle the rear suspension, where the Subaru engine is, as well as 60% of RazzoFab's entire weight. We also want to give props to one of Rev's many resident artists, Damon May, who helps produce many of our RazzoFab segments, and he also teams with Dave to produce the Instagram product Talking Shop with Dave Klym. Check it out for some fascinating shop tips.
I guess what we're going to talk about today is this seat for the RazzoFab. And I designed and built the seat.
We've gotten some interesting questions in the YouTube comments section.
I cannot imagine 400 horsepower in a Fiat 850.
I can't imagine 400 horsepower in a Fiat 850 either. That's why we're doing it. The imagination boggles, so we'll have to experience it.
So please like, subscribe, get notified, and by all means, if you have a question or comment, your voice will be heard.
The importance of hearing from our audience is, while we here think that the RazzoFab is a totally intriguing and fascinating project, we want to make sure that the people who are watching are also involved in how it evolves. We want to produce something that the audience out there will find intriguing. Not everybody is a hardcore car guy and wants to look at what we call fabrication porn, which is some guy with a TIG welder laying down a perfect bead between two pieces of steel. We want to make sure that we explain to people the human side of this program, the technologic side of the program, and the kinds of issues, opportunities, and problems that we encounter as we go along. We can't do that unless we know what tickles the audience's fancy. So let us know.